A very good afternoon to all of you. I am Meenakshi, welcoming you all on behalf of Solar Quarter and the First View Group to the Digital Transformation in Renewable Energy Trends, Technology, and Decision Dilemmas webinar. Before we proceed further, I would like to thank our panel members for their immense support in organizing this event and extend my heartfelt gratitude to our sponsors, Goodby and Matix Consulting, for being our crusaders and making this event possible. Their commitment to promoting sustainable energy solutions is truly commendable. Thank you all for joining us from around the world to delve into the world of renewable energy asset management. Now, I would like to invite Mr. K. Pruvdiraj, Chief Consultant, Matix Solution Private Limited, to give his presentation. Over to you, Mr. Pruvdi.
Hello, can everyone hear?
Yes, sir, you're audible.
Okay.
Sir, you can present your presentation on the screen.
Yes. One second.
Mr. Prithvi.
Yeah, sorry, there is an issue with sharing my screen. Just give me a minute.
Mr. Prithvi, there should be an icon on the bottom of your screen to share your screen.
Yes, I can see that icon, but there is some setting problem. on the screen. If you don't mind, can you give access to Nitin from my team?
Sure, sir. Yes, Mr. Nitin, could you please try sharing your screen? Yes, sir, your screen's visible. Please go ahead. Mr. Prithvi, do we have you with us, sir?
Hello, can you guys
So,
hear
yes, we can hear you, sir. Please go ahead. Your presentation is visible.
me? Yeah. Sorry for the delay. So there is some setting problem. First time you're using this app. So this is Prithvi. So I'm the Chief Consultant and CEO of Matic Solutions. So Matic Solutions is a 6-year-old company. So we are the digital consultants in renewable industry, especially on the solar and wind side. And we are on the digital consulting side, especially not on the O&M consulting or a technical consulting as such. So to start with, as we all know, the traditional way of, calling a consultant is, whoever provides expert advice about a particular subject. But now, the definition has changed. So now the one who can leave behind something of lasting value, which can enhance the ability to deal with present issues as well as cope up with future challenges. So that's the job of a consultant. So Matix is thriving towards, with the present definition or latest, the definition of the market. So before getting into the details of what exactly we do in the digital transformation areas, so we would like to address some of the challenges what asset management companies, EPC companies, and independent service providers, O&M companies, OEM companies. So these companies are facing. So these might be something which you also facing on day-to-day activities. So the first one is, when you have a lot of data coming into place, so you can have some kind of data losses which can be happening on day-to-day basis. So, but you are not sure on what are the reasons, the data losses are happening from. And you might be using specific infrastructure, and it can be either on-premise or on cloud, but you're not sure whether it is an efficient way of storing and managing the data. So whether on-premise is the right option for you or on cloud is the right option for you based on your situation, based on your environment, is one thing which you might be facing on day to day. Then you might be having some kind of product which you might be using for monitoring and analysis, and you are not sure whether it is the best in the market. It might be a little old. Okay, there might be new products available in the market, so you're not sure about it. And you might have done a lot of investments in terms of control center building, and you have invested on infrastructure, products, and manpower. So you are not sure the investments which you made are right, or you can optimize on that. And in terms of the functionalities of the product, whether it is functionally fit for you, the older requirements on what basis you have selected the product are matching the present requirements is something which you need to check it out. And you might be facing some kind of persistent issues on a longer run where you are not having clarity on what is the reason or root cause of that issue. So you have a team who is using this kind of softwares or hardwares, maintaining the hardwares, etc. But you are not sure whether the team is fully effective or effectively using that entire infrastructure setup what you have. Then you might be seeing on day-to-day basis after investing a lot of amount on infrastructure, software, automation, everything. Still, people are doing a lot of things manually, and you are not sure why is that happening and what should be done to avoid all those. And you might be using, as I said, like on an early days you have got into this kind of infrastructure setup or hardware, software, etc. And you might not know when is the right time to enhance or upgrade it. Is it the right time today, or you can wait for 1 or 2 years more? So these are something like when it comes to digitization or infrastructure or software, people might be facing, or people might be thinking on day-to-day basis. So as we all know, every company needs nowadays an ROC center, which is a remote operation center, or you can also call it as network operation center as well as operation control center to manage the assets more efficiently because you have multi-brand OEMs coming into place, you have multiple sites at different locations, so you need to manage the assets efficiently. And Matix is the only company who is focusing upon, especially on the digital side of it, and we are consulting all the clients and helping them to have the best. So basically, when we started Matix, we started with a mission of bridging the gaps between the product suppliers as well as the buyers, because the product suppliers are coming out with some kind of product to fill the market requirements, and the buyer has certain requirements, but there is always a gap between the expectations as well as the deliverables. So we try to start these consulting exercises to fill these gaps and make sure that you know the industry is going towards with closed hands, where both the product companies as well as the buyers are very happy with their input output. Now what Matix has done since last 6 years, we have done in-depth analysis of more than 25 software platforms, and we have worked with more than 10 multinational companies, and we have worked even with top 5 utility companies in the world. And our ROI, whatever investments are done on our consulting exercises, are quickly returned in terms of the value which we created. And we helped all the companies to take right decisions so that they can save, or they saved huge cost savings. And we also, as I mentioned, work with multiple kind of companies. We work with IPPs, we work with ISPs, we work with OEMs as well as software product companies. So what is that we have in Matix? In Matix, we have deep understanding of all the products and companies available in this digitization space, and we follow in-depth and systematic processes. We design tailor-made solutions. It's not standard across all the companies. We made tailored solutions based on the timelines, budgets, and constraints of each and every client. So each and every client's environment is different, their budgets are different. So we created tailor-made solutions for each and every one. And at Matix Consulting, we have experts who are having deep expertise in domain, IT, as well as analytics. And we have professionals from IIT and other prestigious institutions who are our consultants. And we have mixed talent pool of consultants who are young, who can actually bring out some kind of latest technology know-how, as well as we have retired people who are having deep experience and face a lot of issues in their life and overcome those issues with their experience, and who is actually contributing this to us. Now let's get on to what are the areas of consulting Matix deals with. So we actually frame this entire consulting value chain where someone want to start, their control center. So starting till the end. So end-to-end value chain is what, we covered up with our consulting services. To start with, the first one is infrastructure consulting. To start any control center, the first thing what you need to have is infrastructure, because you need data for doing anything. So here we provide comprehensive infrastructure planning services. So we deal with all the latest technologies, and we suggest you that entire solution revolving around infrastructure will be reliable, and we will make sure that the data losses are very minimal for you, and you are having 100% of data safety, and the operations are seamless. So you don't have any issues which are going to be faced in the present environment as well as shortly in the near coming future. As you all know, operational data is wealth for any company, and it's priceless. So we will be addressing this as the primary issue or primary aspect before starting our control center. Next, once the data is ready, then you need a software to make more sense out of the data, get more insights, have some dashboards, have some reports, have some analytics out of it. So for that, if someone want to develop their own software. So we have something called product consulting, where we do develop the world's best in class monitoring and analytics products. So here we create MRDs and PRDs, which are going to be custom made or tailor made for you. And our products, whatever we are going to recommend to you in terms of functionalities, are going to be futuristic, and it is going to have all the industry standards incorporated in it, taken care of. And the products which we are going to recommend to you are going to be highly functional as well as snug fit products. And we provide the inputs from the functional level at a very high level till very in-depth level of technical inputs, where we provide formulas and filters also. So it's from macro to macro level we provide inputs. So as you all know, if you have the best product, you will have best performance and you can have best results. So the next one, if someone want to actually not to develop the product but readily buy from the market. So as I already mentioned to you, we have already evaluated or actually studied, more than 25 software platforms in the market. So we have in-depth knowledge on all the software platforms which is available at present in the market. So we help you based on your requirements to get the best product, for you, which can be onboarded and you can start using it. So here we help you in evaluating, hiring, and contracting process of a certain software product, which can be aligned and which can be fitting rightly to your goals. So here we do qualitative as well as quantitative, analysis to select the right product. So we will take care of both functionally and technically they are matching your requirements. We will assure that timelines, budgets, and constraints, whatever you have within that product is fitting, and we will optimize the investments what you're going to make in that products. So we actually add value in terms of techno commercial negotiation. It means like we negotiate technically and commercially together. So not only technically or not only commercially or not separately, basically. So because of which you will be getting the right product at right price. So once the product is finalized, so you will be implementing the product in your environment. So during that integration and configurations, you need a lot of testing to be done at each and every deliverable, and also at the end of the entire deliverables before going live. So we help you in agile methodology, okay, while implementation, and we help you in on time and efficient deliverables completion. And we also resolve the issues during the deliveries, because we've seen a lot of integration issues, a lot of configuration issues which are being faced. So we help you with our expertise during that stage, so that quickly it can be resolved and move on. And we do thorough testing at each and every stage of deliverables and also at the end, and we will make sure that the implementation is successful within the planned timelines. So basically here we will be making sure that the investments which you are making is effectively utilized. Then, so your product is ready, it is implemented and ready to use. So now you need to have an efficient team to use that product and get some insights and take some decisions out of it. So for this, what we do here is we gather a combined knowledge of analytics, domain, and IT, and we train your team, okay, to early problem identification, and we will help them to reduce the risk and to improve the performance so that your goals will be achieved. So here we'll be helping the client in hiring, building, training, and cultivating a team. So we also, if in case needed, provide our on-site as well as offshore team to help you on this aspect. So we will basically make sure that either our team is sitting there to make more sense out of the data, or either we train your team so that they can effectively use the data, the data as well as the softwares what you're going to use, so that you can make more sense out of it. So this is the last and I mean not the least consulting exercise which we deal with, but this is kind of not in the value chain. This covers the entire value chain. So PP review is a kind of product and process review. So here the previous 5 aspects, whatever we have discussed. So all the five aspects, if someone has already implemented, so we will be doing kind of review or audit to see what are the areas of improvement in those five activities, and if any thing need to be improved upon, so we'll give a detailed recommendations on it. So to just summarize on what exactly we do and what we don't do. So what we don't do is we don't sell any software, we don't sell any hardware, or we don't sell any other products. So what we do is basically we are an owner's engineer. We provide advisory consulting services, and we do stakeholders coordination during all the exercises with OEM, O&M software and hardware companies. So these are some of our partners in all the different categories of IPPs. So we dealt with EDF Renewables, Enel Green Power, who are the top 5 utility companies in the world, and Indian majors in terms of O&M or ISP, Greentech, Param. So then we dealt with even OEMs or EPC providers who are like Siemens Gamesa in wind and Sustain in solar. And we have dealt with software companies like Universe Spacefield and Presento in solar. So these are some of our clients whom we already added, value to our consulting services. Thank you. If you have any queries, you can let me know.
Thank you, Mr. Prithvi, for that insightful presentation. Now I would like to request my team to play the commercial video for Goodby. Now I would like to invite Mr. Jay Young, Senior Solutions Engineer, Could Be Solar Academy, to give the presentation for his company. Over to you, Mr. J.
Hi guys, I'm Jay Young, and I will give you an introduction of our company, and I will give the detailed introduction of the utility solutions. So, can you see my PPT? Okay.
Yes, sir, your screen is visible.
Okay. So 4 parts of my presentation. The first part is the company profile, and next I will give you an introduction of the overall solution of utility part. And third part, we will give a detailed introduction of the products and the monitoring system. And the last part, we'll give some case references. So let's get started with the first part. So Goodwe is a company founded in 2010, and we are a very new company, but we are growing very fast. We went public to stock exchange in 2020, and until now we have 4,600 employees, and 850 of them are from the R&D center. And we also have around 200 overseas employees, and we are growing very fast. In the last year, the turnover is 735 million US dollars. So those are the remarkable events during our history. And like in 2019, we were awarded by Wood Magazine, the world's #1 residential inverter supplier. And in last year, we were the world's top 3 storage inverter supplier, also awarded by Wood Magazine. And in same year, last year, we got the silver medal by the Eco Bodies. And we have offices and branches all over the world, covers Asia, Europe, and America, and also Australia, as well as the sales and service centers, so that we can ensure the pre-sale and after-sale support timely to our customer. And in China, we have totally 4 R&D centers located in 4 different cities. And for the product manufacturing base, we have 2 factories, and one is in our HQ in Suzhou City, and another is in Guangzhou City. And our production capacity for the solar inverters, we have 30 gigawatt per year, and for the batteries, we have 2.1 gigawatt hour. So this is our product family picture, and we covers the product from 0.7 kilowatt to 350 kilowatt. Also, besides the inverters, we have the battery product, the building integrated PV modules, and also the PCS and EV chargers. So today I will give you a detailed introduction of our utility solutions. So this is the overall view of the PV station, and here is the PV modules. It will generate the DC power, and our inverter will convert it to AC, and it will connect it to the MV station and step up to 35 kilowatts or 36 kilowatts. And here is the communication part. This is our data logger, and it can compatible with third-party equipments like tracking system, like the weather stations, and also it can upload the data to the station level monitoring system like the SCADA, the PPC. And from this picture, we not inverter, of course, we can supply the utility inverters, and also we can supply the MV stations up to 40.5 kilowatt. And also the communication part, we have our own data logger, and also we can provide you the station level monitoring system, so that we have a total solution of the utility part. So in next part, I will give you a detailed introduction of our product and the monitoring product. So this is the UT series. This is one of our utility inverters. The maximum output power can reach 350 kilowatts, and it is compatible with majority modules in the market. The DC input current can we can make it 50 ampere and 20 ampere. And for the AC side, we support the AC cable, the maximum to 400 square millimeters, and also we can support the aluminum cables. And for the communication, we can use ICE485, and also we have the POC communication. And this kind of communication is edge POC. It's like a mid-band POC, and the POC is can save the traditional communication cables because it is using the AC cable as a data carrier, and so it can save the cost of the communication cables and also the installation of the cables, and also maybe you can save the the future maintenance of the communication part. And the inverter is integrated a Type 2 SPD, which can ensure the very safety use. And for the IP grade, it can reach IP66, and we have C5 for the option for the correction level. It can also provide the reactive power compensation to the grid. We can give this kind of support to the grid. This is a very high efficiency inverters. The European efficiency can reach 98.8%. And based on our monitoring system, we can provide the IV scan and the diagnosis functions. So in the next page, I will give you a detailed introduction of this function. And also for the PID effects of the modules, we can provide two solutions. One is PID recovery, and another is anti-PID. This is another type of utility inverters. It's the maximum output power is 250 kilowatts, and the most features are similar with the 351. So I can make a table to indicate the differences of the two utility inverters. So first is about the POC. 250 is using the narrow band POC, and the 350 using the mid-band POC, which ensures the faster and more stable communication between the inverter and the data logger. And as for the PID solutions, we for both two inverters, we have the two PID solutions. One is anti-PID. It's like PID prevention, and the PID recovery, it's like the PID repair function. And both inverters, we can guarantee that it will not derating at 40 degrees. The MPPTs are different for the two inverters. And for the SCR, for the 350, we can ensure the minimum SCR is 1.0. So in the market, we noticed that the majority modules are, one type is export 50 ampere, and another type is export 20 ampere. And both 250 and 350 can compatible with the modules, PV modules. And for the PID solution, especially when the utility station in near the seaside or near the lake, or in the very high humidity environment, it is easy to get the PID effect, which will make the PV modules, reduce the life and reduce the power generation. So we have two solutions for the PID effects. In the night, we will give the PID recovery solution. Like we will generate 800 volts between the PV negative to the earth to do the repair work of the PID effect. And during the daylight, we will give the it's similar function. We will generate a small positive voltage between the PV negative to the ground, around 7 or 8 volts. It's like to prevent the modules to get the PID effect. So for this PID effect, we got the 24 hours solutions for the modules. And here's the product highlights. The first is compatibilities, the strong compatibilities, like we compatible with the high current modules, and we can provide the POC or HPOC communication. The SCR for the inverter 350 inverter is very low. It's reach 1.0, and for 250 it's 1.5. And both inverters we have night SVG functions can generate reactive power, and we can reach IP66 and C5 to ensure the inverter reliability of the inverter itself. And for the PID, we have also have the solutions. And as for the communication part, I would like to introduce the data loggers. We call it SCU 3000 or SCU 3000A. So it collects the data from the inverters 350 and 250 through Modbus RTU, and it also can collect the data for the weather station, cleaning robot, and tracking system, and etc. through the Modbus TCP or RTU or IEC 103. So to the monitoring part, we can support the protocol of IEC 104, Modbus TCP, and in future we will support also Goose protocols, and it will upload the data to the SCADA or the PPC. And for the SCU itself, we can provide the fiber ring network. It's like each SCU, each data logger are redundancy, so it can make sure the reliable communication of the communication. So this is the data loggers of the utility. So most of the features are listed here, and I also have introduced. So this is the MV station. It's a transformer station. We integrated the transformer, the MV part, the AV part. Everything is inside the standard container. So we leave the, it's very easy for the transportation and the site installation. And because we have did the majority work at factory and tested, and then we will deliver it to sites. So the MV station, the voltage level is up to 40.5 kV, and currently the capacity is up to 7,000 kVA. And now we are developing the 9,001. Hopefully in the end of this year, there's the 9,000 MVS will come to public. And for the MV part, we support the CVC ring main unit, and everything is in a standard 20 feet containers. So it allows the quick installation and the easy transportation. So the IP code, it is reaching IP54, and the transformer itself is totally designed for outdoor use. So the efficiency is also reach 99.58%. So this kind of product is full tested, and we got the full type test report according to the IEC standard and EN standard. Also, we did the simulation of the heat, temperature rise, wind load, and snow load, so it can ensure the wide working temperature of the MVS. It can ensure also it working properly in the extreme conditions, weather conditions. And for the monitoring part, because for the utility part, it's occupy a very large land, and it is also very challenging for our customer to do the maintenance and the inspection work. So we provide this monitoring solutions to solve this painful point of our customer. So this solar OS station level monitoring system can collect all the data from the PV part, like the module data, the PV module data, the inverter data. We will give you a very overview of the subarray, and it shows some data, some necessary data like the generation of the day and of the history. And you can also export the report, including the data like reactive power, active power, generation of the PV station and of each subarrays. You can customize the report, and just click the export button, and you can have all the history data. So it allows the very convenient digital operation and maintenance. So besides that, we can also do the analysis work. We can analyze the equivalent operating hours, and we have different views to give you a clear overview of the stations, like the overview of the whole station and the device levels view. We can also allow it. And for the inverters upgradation, it is also very convenient. You can just upgrade the document to the system, and you choose the inverters you want to be upgraded, and just one click you can upgrade to the choose inverters. So based on this solar OS, we have the IV scan and the diagnosis. So most of the malfunctions of the PV or the inverters can show the abnormal of the IV curves. So we have the database and collected all the majority IV curves, and it corresponding to a specific malfunction of the PV part, like small cracks, the shadows, the open circuits, and we will give you very good suggestions and of the of what kind of fault it is, and we will give you also a very good advice of the measures you should take. And it is also very high efficiency system, like diagnosis of a station with a capacity of 10 megawatt, it will take less than 10 minutes. For a 100 megawatt station, it will only take 30 minutes. So let's come to the last part. I will give you some case references. So this is PV station in Malaysia. It is around 30 megawatts. And this station, we provide the total solutions. So for the inverters, we supply it, and for the MV stations, and also for the station level monitoring systems, we also supply it. So we provide the overall solution to these stations. And this station is commissioned in March of this year, and it's already running for more than half a year. So everything is fine in this PV station. And next is the 13 megawatt PV station in Germany, and I was there in August. It is also all commissioned in August, and everything is fine here. And this is the station in Korp. It's also in Germany. It's in Hamburg city. Also it's in India. We provide the utility inverters for the PV station. This is the station in China. You can see that all the modules or the inverters are installed above the lake. So in this kind of environment, it's very high humidity, and it's in that city, it's the temperature is also very high. So it is very not friendly for the PV modules. It is easy to get the PID effect, and for our inverter itself, it is just 2.5 meters above from the lake. So the environment, the humidity is very high. But for our inverter, we have the IP66 and C5 corrosion level to ensure the inverter, itself stability. And for the modules, we also can provide the PID solutions to prevent the PID effects. This is the station in China. It's 40 megawatts. It's in a desert place. So this is a very standard shape of the subarray. So for this kind of conditions, you can use larger power inverter like 350. So you will get low cost of the station. And for this station, it's installed on the mountain. So for the station, it's not so easy for installation end of the shape of the subarray is not so standard. So for us, we can give you a very flexible solution because we have the 250 and the 350 two-type utility inverters. So we can, according to the capacity of the subarray, we can give you a flexible design of the PV station. And also, this is station installed in the rooftop. It's industry station. So for the utility inverters can also be used in the large CII conditions. Yeah, so that's all for my presentation. Thank you for your time. And if you have any queries, you can let me know.
Thank you, Mr. Jay, for that insightful presentation. Moving on, asset digitalization is a pivotal advancement in the renewable energy industry, revolutionizing how renewable energy power plants and installations are monitored, operated, and maintained. The digital transformation is driven by a confluence of technological innovation, environmental considerations, and the quest for greener energy efficiency. It encompasses a wide range of tools, systems, and strategies that collectively enhance the performance, longevity, and profitability of assets. As the renewables industry continues to grow, so does the complexity of managing assets efficiently. In this webinar, we delve into the exciting world of asset management digitalization, exploring the trends, technologies, and strategies that are shaping the future of renewable energy sector. So, without further ado, let me introduce our esteemed panel speakers for today. We have with us Dr. Hao Wu Ba, Electrical Engineering Specialist, Super Energy Corporation, Mr. Jay Young, Senior Solution Engineer, Goodby Solar Academy, Mr. Samrit Goyal, CEO, Solar Horizon, Mr. Nikhil Kedkar, Senior Manager, Renewable Energy, Renewable Energy Engineering, Hygenco Green Energies Private Limited, and Mr. Nikhil Kedkar, Senior Manager, Renewable Engineering, Hygenco Green Energies, who will be the moderator for the session. Over to you, Mr. Nikhil.
Thank you, Meenakshi, for this event. It's wonderful and good interactions with all the Mr. Jai. Then over then we discussed about mathematics, what solutions. Yes. Now we have the different stagnation and see different challenges in the terms of renewable industries. So basically, in terms of where we are coming on the artificial intelligence AI methods, and now in the analytics tools, we have different analytic tools also. So predictive energy and what come the energy simulations in the market right now. So over on the process ahead, we would like to present our some of questions on the two three questions based on the IT platforms. I would ask panel on the to enhance on the part of where we how to implement the SCADA systems more and more accurate and more precise in terms of when we are predicting energy and when we are sending data to the NLDC or SLDCs, or maybe the where is hybrid plants, where is renewable plant means solar plants and wind plants both. So we have some certain 15-minute data intervals, or maybe the 10 minutes data intervals. So we need to give some of energy protections with a time period of 10 minutes, 5 minutes to achieve the same things. How how the AI platforms or how the SCADA platforms works uh, in that way. Yeah. Shall we ask the panel on the Mr. Samrit, go ahead.
Nikhil, how about we introduce ourselves as the panelists? Maybe the audience would like to know who's on the panel. I certainly would like to know who are my fellow panelists.
Yes, please, please proceed.
Maybe we can also turn on our videos, guys, so we can see each other. That's much better.
Thank you.
Yeah, I'll just take the opportunity to go first. Guys, I am Sam Goyal. Samrit is my name. Sam is what everybody knows me by. I am the CEO and founder of Solar Horizon. We are a developer and EPC based in Singapore, focused on the commercial and industrial space for rooftop solar. So for me today, I will be liking to comment on some of the key topics such as digitalization in asset management. I believe in application of technology rather than how the coding works. I don't understand that, but I know how to implement technology and how to make it useful in a practical way. So that's going to be one of the topics. The second topic is actually, you just mentioned on it, Nikhil, 15-minute data intervals. No, we need minute by minute. And that's one of the new systems we are implementing, particularly with IoT integration, when we can integrate not only to the existing building management systems as well as the power grid meters, so we can show a holistic level of monitoring rather than a lot of the native monitoring that's at inverter level. So those are the two things. And if we have some time, the third thing I'd like to talk about eventually is peer-to-peer trading of excess energy, particularly in dense solar dense countries or cities like Singapore. We have a lot of generation and backflow that can be used by others. And this is where blockchain comes in. So, anyway, that's a short introduction. Thank you for the time and having me here. Over to the rest of the panelists.
Yes, thank you for your introduction. Hello, everyone. I am Hauvuba from Super Energy Corporation. It's my honor to join the panel discussion today about a very hot topic, I think, digital transformation in renewable energy asset management. So I'd like to briefly introduce about myself as well as Super Energy Corporation. In super energy, we have invested in PV power plants, in wind power plants. We have battery energy storage system, and we also invested in waste to energy plants. And at present, super energy, we are mainly in Thailand and in Vietnam. So up to now, we have 1.4 gigawatt solar power, 50 megawatt wind power, and 136 megawatt hour BESS. All of them are already in operation. And in the meantime, we are developing more than 400 wind power plants, including both onshore and nearshore wind power plants in Vietnam. And we are launching more hybrid PV BESS plants in Thailand under some very special and incentive programs of Thailand to encourage to stabilize the output, the power generation of renewable power plants, specifically for PV. We are highly interested in renewable energy asset digitalization, which for sure that can help us to boost the performance of our renewable energy assets. And on behalf of Super Energy, as a leading investor in renewable energy in Southeast Asia, today I would like to join our panel discussion to share our realistic perspectives and some like of our expectations for the digitalization in renewable energy asset management.
Nikhil, would be great to get an introduction from you too, sir. Would love to know what you do and what your background is.
So, myself, Nikhil, and I'm taking care of renewable energy business over the Hydrogenco Energies. Hydrogenco Energies working on the hydrogen platforms on production of green hydrogens. I'm taking care of renewable energy business on the terms of solar and wind both, and we basically integrate with the renewable portion, renewable parts, solar, doing that with the BESS also. We have the gas business with the production of green hydrogen with the help of electrolyzers. So our customers, we productive at the end customers also, like as a boot model. And yes, that's all.
Great. Any of the other speakers would like to just step up and introduce yourselves so we all know who we're talking with? Nitin, are you there? And yeah, Nitin, can you hear us?
Hi Samrit, yeah, I can hear you. I'm not into the panel. I have helped Prithvi for the presentation from Matix, so I'm
Okay,
not currently
understand.
in the panel. Yeah.
No problem. Thanks for clarifying. Is that the same with Mr. Prithviraj there? Okay, I'll make that assumption. Gentlemen, so it's the three of us. If you don't mind, maybe I can also support some of the discussions. So first of all, great to connect with you both. Good to know that you are in the utility space, particularly with different types of technology, solar, wind, battery, hydrogen. I'm in a different space. I am pure rooftop solar, so I think it's nice to have different elements represented today. How you mentioned about some realistic perspectives, particularly on boosting performance of assets. Maybe we can start there because clearly, as a renewable energy IPP with more than a gigawatt of portfolio, every percentage point, in fact, every basis point probably counts significantly in your ROI. So maybe you would like to share with us what kind of digital technologies you guys are currently using and how you see that from a realistic way actually helping to increase performance of your assets.
Uh, yes, thank you so much for your question, for your like discussion point. So let me check the information. Uh, in super energy, actually, we are like deploying three main solutions for digitalization, for digitalization in solar asset management or wind asset management. So I would like to share the information of one by one. So the first solution that we are deploying is the drone inspection. We use for like visual inspection and thermal inspection of our solar farms.
Cool.
The key point is to detect the anomalies of PV panels. So basically, we use drones for visual inspection and thermal inspection of PV panels. PV scanning and thermal scanning images are the input of, a very like highly sophisticated analysis model based on machine learning or deep learning for image
Mm,
processing and image classifications and data analytics to analyze and identify anomalies. For example, some basic problems such as panel cracking, soiling hotspots, and some other anomalies. They all show some like thermal behaviors that we can use
yes.
drones to scan. And just one sharing that I really want to share, like to show that the importance of digitalization in this sense. So, for example, for our 50 megawatt solar farms, if you want to have a very comprehensive thermal and visual inspection using the drone, it may come up with around like more than 10,000 photos. So some people may think digitalization for to analyze the thermal I mean, the images captured by drone, it would be expensive, but it is very effective. Imagine that, like for 10,000 photos for both visual and thermal scannings, if we have to check by our hands, if we have to check manually, it is like too much time consuming and we may miss some anomalies. It is like unavoidable, I think. So, in this sense, to apply digital like applications or advanced data analytics applications like machine learning based image processing for anomaly classification, it would be really effective for our operators, on-site operators, to check the health conditions of our asset. And the next application of
So sorry, Mr. How I just jump in here. That's a very interesting point. Let's have it as a kind of discussion together. Very interesting. But I guess the point you're making is that replacing manual checking, which also has human error, which also takes a lot of time with digital analytics. I believe it's probably based on pattern recognition. right? And when you talk about
Yes,
machine
yes.
learning, I believe the initial effort has to go into training and setting the baseline. So I guess if you have enough samples of all different data to set the correct baseline, probably a lot of effort and time initially goes up to set that up, and then you can apply it and it can recognize the various patterns. For example, thermal anomalies, which is one of the hardest challenges, right? To find one broken panel, let alone to claim the warranty from the manufacturer. That's another issue EPCs like us have to deal with. But in terms of identifying which is the one panel in the thousands or hundreds of panels, so I understand, and that's a really good point. Nikhil, do you have any just insights to add to that? Because it seems like a big topic of digital analytics when it comes to analyzing different data points.
Yeah, so basically it's like to assess any kind of existing plants when we are talking about the old plants, which is 5 years old. So that basically, because we know all these things are technology driven, all the certain levels of 2 or 3 years, technology is different. So we have to understand the grade that the patterns that is going for. Let's say the earlier we are working with some the ranges of models of polysilicon models. They have the different derivations. Now we are with the top ones. Now we are working with the bifacial models. So the pattern, we have to understand the pattern
Right.
also in the analytics. As far as manual readings, manual understanding, though there will be definitely, you rightly said, there is a manual errors. But in the during the uh, analytics forms, we have to understand technology driven. It will be change as per to year.
That's
That
a
all
really
the
good
collective
point,
data.
because yeah, because let's say in 150 megawatt plant, let's say a relatively new one, you will have the same module, right? But if you're analyzing five or six or 10 different plants, particularly legacy plants from 10 years ago, and each one of those technologies have different degradation. So that's a really interesting point, accounting for the technology advance and the different types of parameters with each generation of technology. Yeah, great insight.
Yes.
Yeah. How back to you? So that was a great real life example. Maybe you can give us another one on your list.
Uh, yes, so and here I can, I mean, the example that I shared was about like a drone inspection. So I would like to share some examples related to the data analytics. Like we use
Mm,
some advanced data analytics models to analyze our operational data. So we know that the operational data of like solar farms or wind farms are time series data. And most of the machine learning applications to analyze that operational data are based on deep learning, or like, which is a subsection of machine learning section. More specifically, the applications of deep neural networks to analyze the
mm,
performance, like for performance assessment of renewable energy assets. And I can list it here some very specific applications that we are
mhm.
deploying in super energy. For example, we apply deep learning models in power generation forecast of solar and wind power plants. So in Vietnam, we have large
Forecasting. Mm.
scale, yes, forecasting problem. In Vietnam, we have large scale solar farm and wind farms connected to the national transmission grid, and like by the regulation, we have to deploy like a full
Curtailment.
function SCADA
Yes,
system. Yes,
sure.
and yes, our SCADA system must be connected to the load dispatch centers of like Electricity Vietnam, as you know, the EVN. They are the only utility in Vietnam for electricity, like generation, transmission, distribution. And so, like by the regulation, we have to integrate a PV or wind power generation forecasting model, and we have to submit, for example, day ahead, hour ahead, or even like with the time step resolution of 15 minutes by regulation up to now. So.
Wow.
If we submit not accurate PV generation forecasting or wind power generation forecasting, it may affect our energy production efficiency by like grid curtailment. Like the role
Exactly,
of
and that's the
yes,
application, isn't it? To because that's what hurts the ROI, right? And as a developer with my roots, I always look at what
yes,
are the risks to achieving our return, and this is where the digitization comes in, and that's another great example. Let me just summarize that
yes,
so I think we can all understand it. Is basically the risk you guys face is that the grid needs to be stable, right? And there's a single grid operator, and we have multiple injection points from different technologies across big countries like India or Vietnam with different resource, renewable energy resource, right? So there's all these different inputs into a grid that needs to manage a stable output. And one of the challenges, as we do know, those who have been experienced in Southeast Asia solar, that the curtailment issue in Vietnam was a reason why a lot of the large scale solar, particularly under Fit 2, faced a lot of challenges, right? A lot of financing challenges. So, with that as a context, could you now perhaps help us explain, yeah, with more maybe a technological explanation, that how does your ability to forecast? So, two questions. One, how does the ability to forecast help you or help the grid operator balance? And then number two, coming back to your digital analytics, how do you, and in English terms, I don't know what deep learning means, but like, how do you use your digital analytic power to arrive at those forecasts?
Yes. Thank you for your question. So for the first question, actually your question is related to the like the responsibility of load dispatch centers of the
Mm,
electricity network of Vietnam. So basically, for example, for day ahead optimal generation scheduling, the load dispatch centers, they have to gather all the generation forecast of the solar, wind, or hydro, any power plants connected to our national transmission grid, so that they can have optimal planning, optimal energy generation scheduling for the like day ahead or hour ahead. So as you can see that if we are the asset owner, if we submit to them the highly accurate PV or wind generation forecast, then they can stabilize this grid. They know that exact, not exactly, no forecast can be exact, but they can know that like tomorrow at that hour, this solar farm can generate that amount of electricity. Then they can schedule, they can dispatch other uh, uh, they can dispatch other power plants in the most economical way to
very
stabilize
good
and to
explained.
like ensure the energy security in the most economical way of our national grid.
Mm.
So uh,
Very good
our
answer. I just want to add
responsibility.
one point. Sorry, just one point before we go to the second question. It's a very good answer, by the way. So I guess this is where we as renewable energy industry can start to compete with thermal power or coal power. Because one of our challenges has always been intermittency and the lack of availability to schedule and dispatch our power. We cannot decide when the electron is going to generate. And I guess this is a really important point, that how we can solve this issue and become more competitive on baseload level is if we can increase our forecasting ability, right? Yeah, nice point.
Yes,
So
yes,
back to you, how
perfect.
on the how do you guys do it now with your technology or your application of analytics?
Yes. So, like as you already mentioned, the key problem of renewable, like variable renewable power plants is their intermittency, and they are considered as non-dispatchable power generation sources. So, like
That's
anyway,
true.
the forecast cannot be perfect. So, the second question about how we like we are, which technologies are we using for the PV and wind power generation forecast? So, we are using deep learning. So deep learning are deep neural networks. So we can use the historical operational data of our solar farm and wind farms to train that model, so that it can forecast the PV and wind power generation of our assets for the next day.
Mm,
And so basically in Vietnam, we have to perform we have to perform week ahead, day ahead, and like hour ahead
hour
forecasting.
ahead.
And
Wow.
Okay.
yes, so
So
that model, that PV or wind generation forecasting model must be integrated in our SCADA system, so that it automatically sends the forecast signal to the load dispatch centers. So like during uh, real time operation basis, the load dispatch center will they have AGC program, which is uh, uh, AGC automation generation control. It automatically calculates to dispatch which generation resources should generate which level of power to stabilize this grid to in a most economical way. So if we submit highly
I hear
accurate
you.
result, then we
They can have their
our
job better.
production
Yeah.
efficiency.
Sure.
Yes.
Nikhil, I'd like to get your views on how it works in India. Obviously, it's a very different market because we don't have a
Yeah.
monopolized
So
grid operator. How do you guys approach the forecasting issue and grid stability issue, particularly with your large scale stuff?
So basically, I was just asking on the that point also, but yes, here we some of points because when we are talking about the hybrid plants,
Mm,
solar and wind, so small scales of the BESS also can injected to the same grid where
mm,
a period of time, let's say for the 2 minutes, 3 minutes of data where you are getting a lot of hours. So for a short period of time, you can get the stable power where you can mitigate that the the result and have
mm.
a delta energy, I mean delta requirement from that BSS. So this is how in terms of when you are fulfilling the or you're fulfilling the requirement, BSS can help support on that. Grid
So how does
stability
the
is very
SCADA work?
important.
Tell us a bit about the SCADA element because clearly this is a maybe you can just for the less tech guys like me, if you could just explain in a nutshell what is the benefit of having the SCADA network and then how bringing it back to the BESS and grid stability. That will be helpful.
Yeah, so it's a very good point when we are talking about the hybrid and talking about the SCADA because ultimately it comes from the PPC. The PPC gives and powers to our the IoT platform where the integrated SCADAs are there. Based on PPC requirement, at send power to send command to the inverters. I mean our tuning substations where solar, wind, and BSS can come together. So ultimately, the central level SCADA monitoring is required, whereas the regional level, so regional level where the solar plants is at maybe solar plant at one location, wind plant with two different locations, and all the
Mm,
come up within the single locations. So even the
interesting.
PSS, that PSS will be there where all these powers are coming up. So
Sorry, just
central
the
level
PSS.
SCADA
What
is
does it
very
stand for?
important.
What does
It's a
PSS?
pulling, it's maybe you can say the combined substation or maybe the pulling substations
Understand.
where the combined power main substation where the all the powers are coming
So
up.
you're injecting
So
solar, wind, maybe eventually hydrogen, and then you have a battery, and all of this is having one central node,
one central
basically
level.
the
So there is
brain.
a central
Okay,
SCADA. There is a central SCADA who communicate
I got you.
with the solar plants, wind plants, and your existing the batteries, storage systems.
So
So
interoperable, basically, right? Interoperability.
yes, yes.
Yeah. Okay, with you. Please continue.
So this is how we can put it in terms of when we are talking about SCADA parts. The major challenge, two major challenge. I mean, because Indian grid sometimes when we're talking about it, and this when we're talking about the grid instability, yes, in that case, because deciding factor of the BSS, deciding factor of the solar, deciding factor of the wind capacity to mitigate that generation requirement, it is quite challenging as of now. So because it's all about the past datas, complete
Mm.
analytics, and the grid intervals, grid patterns, how it requires. So
Then weather
this
patterns
whole
as well,
study,
right? In different, yeah, you have like multiple variables on multiple
yes.
fronts, which you're basically trying to
So
balance
the
and match,
thorough
right?
study, thorough analytics, thorough the simulations required. Not only one, two simulations, hundred of simulations required based on the
My God.
so based on the day-to-day intervals because 365 days we have to run the 60 right. It's 70 versions of files. So these are the challenges we are facing and we
I hear you.
and
You
we
know,
have been
this is so
explored more and
interesting.
more.
Sure. It's so interesting getting your perspective, both of yours, on these different type of technologies combining at grid scale. Allow me to offer some insights how we do it at a micro level, which is with the building and the rooftop, right? So I work in the urban setting where we are putting a lot of panels on a lot of rooftops in Singapore and the region. Let's look at Singapore as a case because it is a very advanced market, not only in terms of its solar maturity. I've been on these panels for the last 10 years. Probably a lot of people have seen me before. But what's really interesting now is solar plus, right? Because unlike land, where I have lots of land and lots of wind here and lots of solar here, in a highly dense city, I have very limited real estate. I have a rooftop. Now, a lot of the rooftops have already got solar. So what next? And this is where, interestingly enough, I mean, I was pulled into this last minute yesterday, but the reason I accepted was I was literally in the middle of putting together some of our new slides, which talks exactly about IoT integration. And in fact, we have recently, I'm not going to name the manufacturer, I don't want to give them free publicity, but we have recently brought on a monitoring system, remote monitoring system, RMS, from India. Usually we used to use the German stuff and whatnot. We've actually found that here in Asia, in our home markets, there's been a lot of development, particularly with the software side, which is a key functionality. And now that you have SCADA, which honestly it's been around for a long time, but now that you have more SCADA systems within energy tech, right, it starts to get interesting. So one application that we're looking at is putting this centralized RMS that can connect to over 100 data points, all via SCADA and RS-45 cable. So what I'm now able to do is, unlike before, for example, our friends at Good, we were showing the inverters. We use, for example, SunGrow or Huawei, whatever. Each of these inverters have their native monitoring system, but it's very basic. It's not plugged into the meter, let alone plugged into the building management system, let alone to the power grid, right? So it's a few slides that it's not very meaningful when we talk about asset optimization. And in the case that both of you gentlemen mentioned about grid stability as one factor, avoiding curtailment as another, avoiding losses in your boot model as another. So for us, how we plan to or are in the process of adding more value to our customers is saying to them, hey guys, I will purchase a much more expensive monitoring system than really the project justifies, because with that monitoring system, I can not only plug into your building management system, so I can start to show you energy efficiency gains or losses in relation to PV generation. Secondly, I can connect to the power grid meters. And in Singapore, we have a very open electricity grid, right? You might be aware that we can feed back with no restriction, unlike Vietnam, where we have certain restriction because it's EVN. But in Singapore, you're able to essentially have a very, what's the word, solar friendly grid. So what happens is the power grid actually comes down to replace the feeders to bidirectional feeders or meters. So now with my solar monitoring, I can connect to the bidirectional feeder. So in real time, I can show my customer how much he's importing or consuming, how much he is exporting. And so that's what we can do currently, which is quite useful. However, the evolution, and as a commercial guy, I always look at how can we apply these technologies, right? One is inventing them in a lab, the other is actually applying them at scale and making more economic value for everybody. So what we see as the future, again, the notion of renewable energy credits in Singapore is a big thing, right? Unlike carbon credits, here we have renewable energy credits, which are very valuable. Because of our land scarcity, a lot of these big tech customers are willing to pay a huge premium to buy RECs, renewable energy credits.
Yes.
So one of the things we wish to do is connect to the respective exchanges. And one of the exchanges is by SP Grid, Singapore Power Grid. So if we can then understand their verification process and then codify it, which I believe it already is, then if we can integrate it via the SCADA interoperable system to our remote monitoring system, I should, in theory, be able to track, not to automatically verify and generate recs and eventually sell them on the exchanges, because then I can put in my AI trading algorithms, right, that will find the seller, and I have my stable variable of generation, and then I can play the exchanges. So that's very exciting, and hopefully one of you guys in your companies can create something like that. I'll be your customer. The second one is with the peer-to-peer energy trading. Now, this is where it gets very interesting in an urban setting because, of course, Singapore is one of the most solar dense cities in the world. Okay, when you look at Google, you see panels all over our country. It's quite amazing. However, the challenge is when I am generating excess power, right now we are commercial industrial players. I don't do residential, but even with CNI, some factories are not there on weekends. In fact, that's a problem in Vietnam, right? That's why you had that 1 megawatt cap and you couldn't exceed, and therefore you have to put lower. And in India, you have boot. It's different, but you have a lot of grid losses. So in Singapore, you have a highly stable grid with no restrictions and full open access. I mean, using the same words. So our idea is, in fact, we've been approached recently by a software developer. I can't name names now. The idea is that instead of us selling back the energy to the grid on a bilateral basis, if we can start applying blockchain to kilowatt hour and start tokenizing energy, and then putting in algorithms that can connect not only to the grid, but also to our solar systems and also to the building management system of the building. In theory, I should be able to do peer to peer energy trading via tokens. While not on an actual basis, the grid obviously electrons will go to the closest point of load, right? We can't dispatch electrons. But if we can create an accounting system that is decentralized and digitized, right, and democratized, then we can start creating mini virtual power plants, but between just normal people and companies. So these are the two applications that we're getting excited about, which is integrating, to summarize, the IoT-based, SCADA-based IoT system to monitor the solar, connect to various points of data on outflow and inflow, and then apply the algorithms and apply the various deep learning and various other tech, which can help us integrate and transact on commercial basis. So yeah, that's just
Yes.
sharing some insights. And maybe if you gentlemen have any comments or any advice or any challenges, I would love to hear it, and I'm sure the audience would too. Yeah, over to either of you. Feel
Uh,
free to step in.
Yes. So, like, I would like to add some more points related to, like, you are talking, two speakers are talking about something like uh, centralized, renewable, centralized and remote management platform, or like asset management platform, or some may call like O&M platform, or computerized
Yes,
maintenance management system. So, I would like to
exactly.
add some points to this discussion point. So recently, about like 2 years recently, many like solution suppliers visited Super Energy. Like basically, Super Energy, we are investor only. We are not manufacturer of solutions. So some solution suppliers visited us and they presented to us their cutting edge solutions for like system monitoring and analytics platform. So basically, this kind of platform digitalize all the procedures related to the like the construction, operation, procurement of our solar and wind assets. And they emphasize that they use machine learning, they use big data or analytics or predictive analytics to analyze our solar and wind assets. So I really I used to ask them a lot about like how we can see the efficiency of that kind of platform. I mean, for sure that that kind of platform brings a lot of convenience to us to manage like a lot of procedures. But what we want to see as the asset owner, we want to see the actionable insight of our asset performance. So
Mm-hmm.
the key point, yes, yes, the key points I really want to emphasize in the keyword, uh, actionable insight of our asset performance, of our
Nice.
asset
Mm-hmm.
health conditions. The key reason is we really hope that someone can analyze our rich operational data around like already 5 years or 4 years historical data. The data is there and just there. Up to now, the data is not deployed effectively yet. So we hope that there is a solution that can analyze our assets, allow us to see the actionable insight of our asset health conditions so that we can allocate our equipment, like spare equipment and human resources optimally. We can make like optimal preventive, predictive maintenance scheduling. That is one of the key points that I really want to deliver to like solution suppliers today. Uh, like uh, yeah, for sure that this kind of platform allows us to see the overall status of our assets from multiple locations, but really want to see the actionable insights to boost the performance of our assets. Yes.
Yeah, that's a really good point, How. I'm so glad you said that
Yes.
because, I love that. I'm going to start using this keyword, actionable insight, because it's easy for someone to come and say, I can do this, I can do that, blah, 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 blah. But how can we as business owners actually have actionable insights to see the increase in efficiency? One good point you made was on the maintenance and the process and the digitization of that. I want to pick that up. FYI, we have about 10 minutes left, but I just want to bring it back to Nikhil. How do you understand actionable insights, right? What are some actionable insights that you would, as an asset owner or asset manager, like to be able to gain from technology deployment, digitization particularly?
Yeah. So I mean, this before assessing any points, yes, uh, the technology that we are working on right now, it's a game-changing technologies. Right? We are working with the say hybrid plants. We are working with the hydrogen plants. We are working with the EV battery charging plants. We are working with the rooftops also. We are working with different floating solar. So first we need to understand when we are talking about the assets, any kind of 100 megawatt assets. On
Hmm.
that, which of the kind of it is utilizing for? Whether it is especially for the grid interactive of selling the power only, or it is for the battery charging stations for the charging batteries, or maybe it is for the residential or maybe the commercial utilizations of energies. So to understand those points, let's say for cluster of capacities, 100 megawatt, maybe the of 10 megawatt into 10 numbers, or maybe the of 50 megawatt into two numbers that have the different certain technologies. Trackers also will there. Then again, their fixed tail systems will be there, or maybe in the wind types there is a wind turbines. Earlier we were working on the stem of small capacity of 1.5 1.7 megawatt wind turbines. Now it is coming with the 2 megawatt wind WTGs. So the patterns that they have, they're different. So this technology we need to understand, and yes, before getting into it, to get and acquire those plants, or maybe the taking those plants, we need to get previous data, O&M data. What are their SOPs? What are their
Hmm.
the back chains? How many interventions between the grid and the generators? Because sometimes generators are giving the 100 megawatt full capacity, but maybe the utility grid at the same time they're not required, or maybe the certain curtailment requirement. So these patterns we need to understand. So
Hmm.
technology wise, maybe the let's say there is the technology of trackers and fixes. So these integrations we need to understand.
Yeah, that's a really good
Probably
point. I
you
like how
can.
you started with defining what is the application, right? Ultimately,
Yes.
before deciding what is the technology, we need to figure out what is the problem we're trying to solve, right? So I like that. And then secondly, to look at existing patterns within those problems, right? We're not the first trying to solve these problems. So clearly there is a lot of patterns out there that we can then specify. And then the third point being is to then select the appropriate technology based on the historical data. And I think how, you guys should talk, maybe they can come and analyze your data because that's
Yes.
basically what Nichols been sharing. But anyway, I want to use this last 5 7 minutes to pick up on another interesting aspect of digitization. The hosts have asked me to wrap it up, but give me 5 minutes. It's actually interesting. Let's talk about it. So the digitization of the process of development, construction, EPC, operation management, right? So in our business, we have origination, right? In your case, with land acquisition, building permits, licensing. In my case, finding the right building owner, doing the site surveys, proposals, designs. Then when we have execution, then all of the submissions, approvals. Then when we have 5 or 7 or 10 different projects, each at different stages with different subcontractors, getting the right reports, seeing the quality control. Then we get into operation and maintenance, right? Then of course our monitoring, our trend lines, our guarantees, or the guarantees we expect from the contractors. So this whole process, frankly, is ripe for disruption via digitalization. Uh, it's not something new. A number of companies over the last, I would say, I've seen it maybe the last 5 years, have been trying to create easy to use interfaces for developers and EPCs and IPPs to manage this process. But the truth is, um, so far, again, I've used a bunch of different platforms. What we as a company decided, and I've spent the last 3 months, another reason I decided to take this last minute thing was we believe we have to customize and build it ourselves. Not necessarily code it or go make a whole new proprietary project management platform and then compete with Microsoft. No. But it is to use existing technologies or frameworks, but customizing each bloody module to each
Yes,
real life incident. And now with we call our project control room, it's about to be rolled out. There's modules for my accounts team, for my finance team, for my QC team. There's modules for our logistics, there's modules for safety. In some cases for license and permitting, which Singapore is notorious for, I have 160 different steps. In each license has some 45 different steps, right? And then coming to my reporting, I'm creating forms for my subcons instead of sending WhatsApp updates and photos and then 6 of my guys busy transcribing all this stuff. Rather, I create a easy for use form. They can punch it in. And the key here is data capture and automation, right? There's no point me having a back office in India. Right now, I'm managing 3 different countries. So no point me having a back office full of staff and human beings when I can have a system that can capture all the data points and then automate it on the task reminders. And then for me as management, visualize it nicely and show me what's happening in the different aspects. So Meenakshi, I can see you there. Give us 2 minutes, please, to finish this. So, how are you guys doing this? How at your scale, which is huge? And then we'd love to hear the same from Nikhil, and then we can wrap up.
Uh, so, like, let me share our perspective before wrapping up our panel discussion. I think our panel discussion today is very exciting and interesting. So you see the long
Same.
list of questions that we cannot answer all. So, I will provide a very brief and concrete summary. So, digital transformation in renewable energy, it doesn't mean that we do digitalization for this industry from scratch. There are already a lot of solutions for many procedures. For example, we have SAP, which can handle like a lot of procedures. So so I just want to deliver the key message is for digitalization in renewable energy. Try to apply technologies to boost the performance of our of like solar and green or renewable energy assets. That's all from my side. Yeah.
Yeah, really good summary and a really good point you've made today, How. I enjoyed listening to you, and thanks for sharing your experience. Nikhil, over to you to just share some closing insights and protect and perhaps comment on what I had asked earlier too.
yeah. I mean, again, digital, it's a very it's very brief word, but to to uh, to getting into it, digitalize as a solar platforms or maybe the wind platforms, where to let's say if I'm a consumer and one another way is the generators. So I have the flexibility to use of anything. Like I want to sometimes I have the good amount of energy generation from solar. I have good amount of from the wind. I have the digital flexibility that I can first I will choose the solar and wind. I'm a free to use of I'm a consumer. I'm a free to use of solar, either solar or wind.
Electron is
It's a
electron,
kind
right?
of
Yeah.
flexibility. It's, it's a kind of flexibility that gives only digitalizations.
Yeah,
So as a
really
brief,
nice point.
maybe the upcoming future, upcoming we will just open it the points. Upcoming future with the digitalized, like I'm a consumer with the free to use of sometimes in solar, sometimes I am a free to even I am a free to choose either of solar, either of wind. or either of batteries or either sources, hydrogen fuel
Yeah,
cells.
I can visualize that on my app. One fine day, I'm like, wind seems nicer today. Let me choose wind. Like that
Yes.
Goodwe video I had, you can choose the different things. So look, I see
So
two
this,
of the interesting questions. Let me just allow me guys to just quickly address them. We've already talked about them. That's why I don't usually do specific Q&A, because if we're all listening, we pick up the insights. But look, the first question, while choosing the right technology partner, how to consider the key points. I think, Meenakshi, how you said it really well, actionable insights, right? Ask the guys who are making you the pitch, what are the actionable insights that they can provide you that can boost the efficiency of your technology, your assets, or your team, or your efficiency, and then ask them to guarantee it in some way. That usually weeds out the guys who are BSing. Coming to the SCADA product data and right skill teams, well, it's clear you need human beings as well. We are still not obsolete, and we never will be. So obviously, having a digital tool, be that AI based or analytics based, it's all about enhancing our efficiency, which is another key message that Hal left us with. So yeah, the challenges are pretty simple. Man and machine should be able to talk to each other, and we should be able to respect each other and make sure we are deploying it by selecting the right problem to solve. That's what Nikhil said. Finding the existing patterns and looking at the existing data, and then try to create a customized solution using existing technology rather than reinventing the wheel. So I hope that answers those questions. Virtual metering. What was that question, Meenakshi? You can flash that up. Yeah, we talked about this. I had actually mentioned about it, guys. You can look at the recording once again. Meenakshi, any other questions that are new or something we haven't covered?
Mr. Samrit, that's it for now.
Okay, sounds good. So thank you, everybody. My closing
yes,
comment before we hand it back to the hosts is that, guys, I really enjoyed this panel. I'd like to connect with both of you separately. Let's do that. Anytime you visit Singapore, look me up. And to the audience, guys, frankly, we as panelists are not going to have time to look at sales pitches about new technology and stuff in the Q&A. I think it's better to respect the Q&A to actually ask meaningful questions, because we're here to share our time, not sell our products. And secondly, to the hosts, thanks you all for having us today. Very nice topic. And, thank you, everybody.
thank you. Thank you.
Yes,
Big
thank
thanks
you,
to all
everyone.
our
And
speakers for this wonderful session. We also want to thank our attendees for extending their valuable time, and a special thanks to our partners, Goodby and Matix Consulting, for their immense support to organize this event. We promise to be back soon with more exciting sessions. The floor is now open for networking. Thank you, everyone.
Thank you, everybody. Have a good day. See you.
thank you, everyone. Hope that you enjoyed our panel discussion. Yes.
I certainly did, guys. Thanks. See you.